Hello students, Mr. Courtney here. In this video, we're talking about aqueous solutions and solubility, and we'll be specifically talking about solubility here. Our objectives will be to define solubility and determine the solubility of a substance in water, and then we'll be identifying the precipitate formed in a precipitation reaction. A solution is a type of mixture, and we have to remember this. A mixture can be heterogeneous or non-uniform in composition. What this means is that we can still see the individual pieces that make up the mixture. So here we have these pieces of metal, iron filings, and sulfur. We can see the iron filings and we still have the sulfur. So we see two distinct phases. Or we can have a homogeneous solution, which is uniform in composition. When we look at it, we can't tell one part is different from the other. So we cannot identify which is the water and which is the Kool-Aid. So we've had the mixture of Kool-Aid and water. So it looks the same throughout. So that's a homogeneous solution. So a solution is really defined as a homogeneous mixture of a solute and a solvent. And they can be different types of solutions. We can have solid solutions, like an alloy, which is a mixture of metals. So metals are melted or they're molten and they're mixed evenly and then allowed to cool. So something like brass, that would be an example of an alloy that is a solution. We have gaseous mixtures, like air. It's just a mixture of gases, and when gases mix, they would mix evenly. So we have a gaseous solution. And then we have aqueous solution, where we have solutes or substances dissolved in water. And this is going to be the one we're going to be focusing on in this unit, talking about solutes dissolved in water, so giving us an aqueous solution. So we have water and salt. So we place salt in water to give us a salt water solution. So that means that salt is our solute. That is, it means it's the substance being dissolved. The solvent is what is doing the dissolving, so that is water. So whenever we have an aqueous solution, water is always going to be the solvent. So in an aqueous solution, we always dissolve something in water. So water is always going to be the solvent. So we have water as a polar molecule. What does it mean when we say that it's polar? It means that we have different regions that have different charge. So one end would have a positive or a slightly positive, and one end would have a slightly negative charge. Why is water polar? Water is polar because oxygen is more electronegative than hydrogen. So we have to remember electronegativity trend. Oxygen, because it's more electronegative, is going to pull stronger on the shared electrons, which is shown here. So we have our shared electrons here, but oxygen has a stronger pull on these shared electrons. So that means the shared electrons are going to be closer to oxygen. And they're closer to oxygen, and since electrons are negatively charged, oxygen will have a slight negative charge here. This sign means delta. This sign is delta, and it means partial or a slight. So that means a slight negative, partial positive, or a partial negative here. So this shows us the direction that oxygen is pulling more on these shared electrons. So it has a slightly negative charge. So that means the oxygen region will be slightly negative, and the hydrogen will be slightly positive. So that gives water two areas of distinct charges, of different charges, so it makes it polar. Because water is polar, it can dissolve polar covalent substances and ionic compounds or ionic substances. When a substance dissolves in water, they break up into the individual pieces, the smallest particles that make up the substance. And that is called dissolution. When ionic compounds break up, they're going to break up into ions, because ions are the smallest particles that make up ionic compounds. So for example, we have the sodium chloride crystal, sodium and chloride ions. When they break apart, they're going to separate into the positively charged sodium ions and the negatively charged chloride ions. But look at the interaction between the water molecules and these ions. Sodium is positively charged. Oxygen here has a slight negative charge. So the slight negative charge of oxygen and the positive charge of the sodium ions, they're attracted to each other. Let's look at the chloride. Chloride is negatively charged. The hydrogens on water molecules are slightly positive, so they are attracted towards the negatively charged ions. So when substances dissolve, they seem to disappear because they break up into particles or pieces that are too small for us to see with the naked eye. So that's why we say dissolution. So they break up into the smallest pieces. They don't disappear. They just break up into small pieces that we cannot see in the solution. So solubility. What is solubility? It is the ability of a substance to be able to dissociate in a given solvent. And in this unit, as I said before, we're going to be talking about water as the solvent. So here we're looking at how well does this substance dissociate or break up when it's placed in water. Some substance will dissociate fully. They will dissociate completely. So that will make them highly soluble. Then there are those that are going to dissociate partially. They are slightly soluble, so they're soluble to an extent. And there are those that are not able to dissociate, so they're insoluble. So how do we tell if a substance is soluble or insoluble in water? We use the solubility rules. And there are different ways you'll see the solubility rules presented to you. You'll see it in this form, or you may see it in just a worded form. So these ions here are all soluble in water. So we have the right column here, which contains the common exceptions. So all these ions are going to be soluble. And the right column contains the exceptions. So if a compound contains one ion from the left here and one from the right where you have the exceptions, then it's going to be insoluble. So let's look at some examples of these. So we have calcium bromide. So calcium bromide, we find our bromide ion, and we say that all compounds of bromide ions are normally soluble with the exception of silver, lead, and mercury. Since calcium is not an exception to the rule, then calcium bromide will be soluble. Lead bromide. Lead bromide is insoluble because lead is an exception to the solubility of bromides. So look at, we have bromides are normally soluble and lead is one of our exception here. So that makes the substance insoluble. Lead nitrate is soluble because nitrate is not an exception to the rule. And since it's not an exception, and plus, sorry, we're looking at this one here. All nitrates are soluble. All right, so I was looking at the wrong one there. So we have all nitrates are soluble. There are no exceptions to the rule. So lead nitrate is going to be soluble. All right, these ions here are insoluble in water. So these ions are normally going to be insoluble in water when they're in a compound. And these are the common exceptions. So if they're paired, if carbonate is paired with ammonium, it's going to be soluble. Normally, it's insoluble. So if it's paired with ammonium and the alkaline metals, what are alkaline metals? Remember, they are the group 1 metals, the cations of the group 1 metals. You need to be familiar with that. So again, if it contains one from the left and one from the right, then it's going to make it soluble. Let's get some examples. Calcium carbonate. Calcium carbonate is insoluble. Why is it insoluble? So we have carbonates are normally insoluble. Then we look at our common exceptions. The common exceptions are alkaline metals. Calcium is an alkaline earth metal, so that is not one of the exceptions. So calcium carbonate is insoluble. Sodium carbonate, it's soluble because we have alkaline metals are an exception to the insolubility of carbonates. Remember, sodium is in group 1, that's why it's an alkaline metal. Magnesium hydroxide is insoluble. Hydroxides are normally insoluble, as we see here. But the exceptions are ammonium ions Group 1 metal cations, calcium, strontium, and barium. Magnesium is not an exception, so that makes magnesium hydroxide insoluble. Calcium hydroxide is soluble, because although most hydroxides are insoluble, calcium is an exception to the insolubility of carbonates. So that's how you go about using these rules to determine the solubility of compounds. So let's look at these nitrates. We have magnesium nitrate. And if you look at your rules, you know that all nitrates are soluble. So that's going to make it soluble. Barium hydroxide. Most hydroxides are insoluble. And barium is one of the exceptions. So that makes it soluble. Iron 3 sulfide. Iron 3 sulfides Sulfides are normally insoluble unless they're paired with compounds of ammonium, alkali metal cations, calcium, strontium, and barium. So iron is not one of our exceptions, so that makes it insoluble. Strontium hydroxide. Hydroxides are normally insoluble. Strontium is one of the exceptions to that rule, so that makes it soluble. Aluminum phosphate. Phosphates are normally insoluble. Aluminum is not one of the exceptions, so that makes it insoluble. Chlorides. Most chlorides are soluble. Strontium is not one of the exceptions. But with silver chloride now, silver is one of the exceptions to the solubility of chlorides, so that makes it insoluble. Strontium nitrate. All nitrates are soluble. Sodium sulfate. All right, most sulfates are soluble. Sodium is not one of the exceptions. All nitrates are soluble. Mercury 2 chloride. If chloride is paired with mercury, it's going to be insoluble because mercury 2 is one of the exceptions to the solubility of chlorides. Calcium chloride is going to be soluble because calcium is not one of the exceptions to the solubility of chloride. Okay, so a precipitation reaction. What is a precipitation reaction? A precipitation reaction occurs when we take two aqueous solutions and we mix them and they react. They have a chemical reaction and they give us a solid product. And that solid product is what we call a precipitate. Hence the reason it's called a precipitation reaction. So you see like a solid falling out of solution, which is called precipitation. So if we look at this example, we start with lead nitrate and potassium iodide. If you look at them, they're two clear solutions. They're aqueous solutions. So the lead nitrate is soluble and potassium iodide is also soluble. So they've broken up into the different ions when they're dissolved in water. But when you mix them, we get potassium nitrate and lead iodide. But lead iodide is not soluble. Because remember we talked about iodides are normally soluble, but compounds of lead and iodide are insoluble. So this yellow substance you're seeing here is our yellow solid. Now it may not look like a solid initially, but when you let it settle, you can see the yellow substance settling at the bottom, and this is our solid. This is our precipitate. So that's why we call it a precipitation reaction. So what is really happening as these substances are mixed? So we have our reaction, lead nitrate. We said lead nitrate is soluble, so it breaks up, it dissociates. So we have lead nitrate, negatively charged. The positively charged regions of water molecule are attracted to it. The lead is positively charged, so the negatively charged region of water is attracted to it. Then we have our potassium iodide. Positive ions, potassium ions, and our negatively charged iodide ions. But when they mix, they give us this precipitate here of lead to iodide. So these two are not, when they're combined, they're not soluble. But look, we still have our potassium and our nitrates in solution. So still this substance here, the potassium ions and the nitrate ions are still dissolved. They're still free in the solution. Hence we say they're still aqueous. But since lead and iodide combine to give us a solid product, or a product that is insoluble, we formed a compound between them, and that compound will not dissolve in water. So if you're given a reaction, you're asked to determine which product is the precipitate or which substance is the precipitate. Now remember, to be a precipitate, it must be formed. So all these substances on the left side of the reaction will be soluble. One of these on the right will be insoluble. So we look at our products, and we just did this one. We know iodides are normally soluble, but if it's paired with lead, it's going to be insoluble. So that's our precipitate. And then you should know sodium chloride is a common name, is a name for a table salt. And we look at our rules. Chlorides are normally soluble. Sodium is not an exception. Carbonates are normally insoluble. Calcium is not an exception, so that's our precipitate. All nitrates are soluble. So sodium nitrate is going to be soluble. Chlorides are soluble except when they're paired with lead, because lead is one of the exceptions to chlorides. So that's our precipitate. Nitrates, again, all nitrates are soluble. Bromides are soluble except when they're paired with silver, mercury, or lead. So that's going to be our precipitate. By now you should be seeing the trend as to how we go about finding our precipitate in the reactions. So next one, again, we already determined that sodium chloride is soluble. We look at our sulfates. Sulfates are normally soluble except if they're paired with strontium, barium, lead, and mercury too. And here it's paired with barium. So barium is an exception to the solubility of sulfates. Cyanides. All cyanides are soluble. Sulfates are normally soluble. Strontium is one of the exceptions to the solubility. So this is our precipitate. Phosphates. Phosphates are normally insoluble. Magnesium is not an exception to the solubility of phosphates. So that means magnesium phosphate is our precipitate. All nitrates are soluble. We know when chlorides are paired with mercury, when a chloride is paired with mercury, it's going to be insoluble. So that is our precipitate. All right. So that takes us to the end of this lesson. I hope we were able to clarify some things here. And until the next time, I'm out. Blessings.